I hope I am audible. So I'll just update the stream title. How do we do that?
I'm gonna be honest. Okay, guys, listen. For those of you just coming in,
Okay, let's go to stream manager. Think we can. I think I have to just decrease this a bit. Who is it now? Okay, so I'm just trying to set up the mic. How good is the audio? I'm not sure. Okay, I think that's. How good is the audio? I'm not sure. Okay. I think we can just go to. Oh, okay. How do I update the title of this stream? Let's go here. It's been very long since I have done a stream, so that's the reason. I'm not sure where it is. So if I go to my channel, okay, I think this is good. Writing code, that's it too. Okay, so the agenda for this stream is to create something. What do you say? 1 second. Yeah, so the agenda for this stream is going to be, we're trying to write an in-memory database, you could say, similar to something like Redis, but not at that scale. Just a toy kind of thing, you could say. Yeah, so the problem we are going to solve is we're going to store data in the in-memory DB. So this is going to yeah, so this is going to contain the key value pairs kind of thing, right? So if you send in some key value, it's going to store it, and then we can get the value by key. So what Redis does is that it stores in memory, but also it gives us persistence as well. So behind this there is a persistent layer. So you could say persistent layer. That could be anything. For now I'm just saying that as a persistent layer. Yeah. So this is not the focus for now. We need to get this working. After that I think we could get the persistent layer working even though. So this could be in many ways. So that what I'm thinking is that this could be a REST call. There will be like multiple interfaces to this. So there could be a REST call. Why is this like this? Okay. It could be via REST or again it could be via, let's say, CLI. Anyway, like it's just a request coming from anywhere. We could build it as a standalone thing. Whatever the interface is, we could build this as a standalone, we could say server kind of thing, but I think it's better if we keep it as a REST service and kind of server kind of thing. So this is going to be a part of a server, so that we could call the APIs in order to get and set the values. So it would be something like, if you do a get request to slash some key, you must get some value back if it is present in the DB. And in the same way, if you're going to do what is it, at the same time, if you're going to do a post request to some key with you could do however you want. If you want to do, you can say key is this and the value is this, and then that could say okay, that we could give back okay after storing this, right? So we are going to do this in Go, because that is I'm very familiar with, and I'm not sure about the, so this is going to be part one of I don't know how many series it's going to take, but yeah, so the goal for today's stream is to get the in-memory DBs in initialization setup. So basically to get the server working and to get the DB ready, at least to get the APIs ready. So that should do the work. And for this, I think what else is there? Yep. So persistent layer, it's not going to be any DB or anything. We are going to just store it on disk. So this will be persistent on disk. And in memory, I think whenever you restart the server, everything in this in memory DB goes away. You have to do that again. So that's where our persistent layer comes in. And yeah, I think we could remove the CLI here because we're going to get rest. I'm just confirming if I'm audible. So I think we could start. Okay. Yeah, I hope I'm audible. So yeah, before that, is there anything to do? We could just draw a line here and here. I don't know. Yeah. Yeah, so there are a couple of calls. We're trying to keep it very simple. We are having a couple of calls just to set and get a value, and then we are going to just use that value. So this is going to be up next, but for now I think we can focus on this today. Yeah, I think we could start with this. Okay, so I'll just go into my Go directory and I'm going to do, we could call this inmemdb. It's not actually inmem, but okay, inmemdb. So we could do a Go mod in it, and we could just say main.go. So we have initialized a Go repository here, and we'll also do a git init for some reason. Yeah, we have the main.go here and Go mod as well. So for this, I don't think we'll need any outer packages, but I think we could install if we need that. But oh yeah, for the server, I think we need something. So I'm not sure because it's too long I've been into the server thing, but I'll just check if what servers are available. So server in the sense, we have, I think we have Fiber, we have what do you say, Gorilla. I think it's now deprecated, but we did have Fiber. Yeah, we do have Fiber. I think we can start using this. Yeah, it's pretty simple here. Yeah, I'll just use this. I'll just install that. So other than that, we will need to test this. I think we could do curl for that. That should be fine. Okay, so we have this package, and I'm just writing the boilerplate for this. Okay, what happened? I think it's stuck. Oh, it's not writing for some reason. Okay. What? It's getting stuck. I'm not able to save the file actually. It's getting stuck. And why is it? No idea. Oh yeah, now it's writing. It might be the LSP, I guess. Okay. So with the fiber in place, I think we could just try this. One thing is, I'll just open this in a Tmux tab, and I'll open another pane so that I can switch between them. And I'll open the tree. Okay, this says so, but let's try running the main. We did do go get, right? Okay, we needs v3. Let's try running. Okay, now if you go to localhost 3000, yeah, we get this output here. So our server is running. So we have this, but we don't actually want this. Let's run it at 3000. Let's remove the comments. So let's add a file here, db.go, and what are we gonna do is just going to say package main. It's going to be same package. I'm not going to make it too complicated. So I'm also going to keep it here itself. Whatever the logic is going to come in. So as we said, this is going to be get / some key. So I have to see how to pass a query into this, the parameter. Okay, we could do this. So I could do this from key, and I could get it from params like this. I'll send the key back. I think we have to restart this manually. So if I do 3000, it won't get, but if I do something like this, I get that back. Yeah, so whatever I pass here, I'm just returning it here. So now what I want to do is I need to have some kind of data structure which can hold the the keys and values. So for that I'll make use of db.go here. So let's say db. So db is going to be a struct. So this db is going to hold all the information about the keys and values. So this will of course contain the key. There is going to be interface, and it's going to be value. There's going to be value as well, which is an interface. The reason we are going to take interface here is that it can be any value, right? Okay, let's do that. It can be any value, right? So it can be integer, string, or anything, so that we don't know what it's going to be. And so technically it's a string because we are getting that from the params, but I'm not sure. We could again look back into that. So so for now we could do this. Let's go back to main. So we need, as I said, we need another route which is going to do the post call. Yeah, so this is going to be slash, and again we're going to func fiber, whatever it is above. Yeah, this is going to be the same. So here when you're going to get from the body, how do you get from the body? Post. Why is there no post here? How do I get the data from post? I think so let's try sending the string back. Here it's going to be c dot body. I think so. So let's open Postman for this. Before that, I'll just restart the server. Yeah. So what I'm going to do is I'm going to do 3000 slash, just do 3000. It's going to be post request, and here I'm going to send a JSON with, let's say, key is 1 and value is going to be, let's say, 100. So if I send this, I get this as a string entirely. So I don't want that actually. Whatever, okay, because we are doing string, we are going to get that. So I think we can marshal that into a struct directly. I'm not sure how to do that. Okay, this is in bytes. Yeah, so if it is in bytes, I think we could, let's try that actually. We have a type here. So this is a request. Let's say the request. Put request. I know it's not a good name, but okay. Key is going to be a string, value is going to be a string, but in JSON I think it's going to be key, and again in JSON it's going to be a value. Oh, isn't it key? Okay, let's see. JSON tag go struct. Okay, give it like this. And I did it like that, right? Oh, okay, and it double ticks. Okay, so now could do JSON dot marshal. Wait. Marshal, no, byte to struct go. Not sure how did I do this previously. Yeah, so you have a struct, and okay, this is marshal is the reverse of what I'm thinking, I guess. Yeah, so we have this byte data. Okay, so you just create the, let's say, request variable, and then you say JSON dot unmarshal. The data is we get from this, and this is R, and we're going to say key is going to be, I'm just going to do how do you say, as printf. Yeah. So key is going to be this, and value is going to be this. This is not required, like we can directly do the whatever operation we want, but I'm just verifying this. Why this is not restarting? I have to manually restart every time. Okay, I go to Postman, and if I do this, key is 1 and value is no. Okay, because this is something, this is integer and we have given a string here. This has to be any. So let's try this now. Okay, so here this has to be, while printing we can't do this, we have to print the value instead of specific string, and if we do now, yeah, we get this. So we are getting the key and value, so I think we can start storing them directly. So in dbgo, right, so we have this key and value which is going to store, but the problem is there can be multiple key and values, and it's going to be a map kind of thing. We need to get the value from the key. So for that, I don't think this is going to work. What I think is we need something like a map. I don't know how to initialize that. Let's say db, which is a map of string, I guess. Oh, this is any. And if I go to this, I'll just comment out this. So this db is a map which can contain key and value. So we need to access this db anywhere in this. We can access, but before that we have to initialize that. So I could say db is make with this map of any, so that it gets some memory allocated. And after that, so whenever I get a post request, like put request to put a key and a value, I could just say db of whatever it is, key is value, and I can just say okay, right? Is there any okay? No. I can just send the status 200, and I can also send no. Okay, let's just send 200. And here when we are getting, we get the value, and if it's okay or not from db, we just do db of key. So if not okay, we need to handle that, else we'll just say v. I think we need to convert that into string, which is v, or I think we need to typecast it. So if it's not okay, then we are going to return, what are we going to return? We're going to send status that it's not okay, which means 400, it's a bad request. Let's try this. So if I come here, I just do this, I get a okay, and then if I do a get request for /1, what happened? Okay, it's float and not string. Okay, instead of string we can just say send. Okay, need to send the this thing exactly. So string doesn't work because this doesn't work for interface if it's different specifier at all. What else can we do? This is any. So what I don't want to do is store every information like its type and all. I just want to keep it very simple for now. Whatever I get, I just want it to return. Okay, let's take the help of fiber. Is there any response? Okay, JSON response is awesome. Okay, yeah, c.json. Yeah, this should work with this. No. And oh, okay. I think we can do fiber.map, and we could say, why can't I just send a value? Okay, for now I'll just send the value like this. V. Right? I'll just run the server again and again. So if you see, if I do this, right, I get 400 because that doesn't exist because we restarted the server. I have to go here, remove. I'll do one thing. So I'll do a get here for this, and post would be like this. This okay, and yeah, we get the value here. But the problem is when we restart it, it goes. But that's the beauty of in-memory key value store. But there's one problem with the current implementation, which is locks, or you could say at any given time, right? Anyone can read this map. Like, we are not saying that only one person should read this. So there can be multiple people updating the same key, and we don't know who might get the correct one or the updated one. So that there's a problem with that. And this is very common in in-memory maps. So what we usually do is we put a lock in front of it and then say that we do not want to access this until this lock is released by someone else. So it's basically a reference counter kind of thing. But there's a way to do that. I think we could wrap this up in a struct itself. So like how we did here. So here, instead of, okay, let's say it's not a map, so it's a struct. DB is a struct. So DB contains the key value map, which is any and any. And I think, let's say lock. I think Go has mutex. How do we do that? So okay, yeah, sync.music mutex. So we could use that lock to see if this struct entirely is being accessed by anyone else. And so there are two types of locks. One is reader and writer. Sorry, yeah, both of them, reader and writer. When someone is writing to the DB, right, you have to make sure that writing lock is not taken by anyone else. But when we are reading, the reading lock can be taken by anyone else, but the writing lock should not be taken by anyone else. So there are some rules for that. And yeah, so what we want to do is, so here I don't want to do this. So DB is going to be a struct. DB is going to be DB. What should we name this? DB. And db.kv of key is this. And similarly, db of kv of key. Yeah, I could say that db is db. And here I could say db make. How do you? I could just say, I don't know if I could say that here. Yeah, I could not say that here. but at the same time we need that here. I'll try doing that by saying db is going to be db, right? So right now we don't have anything to pass, but actually we have, because this map we have to initialize this. Like similarly how did we did that before? So it's kv is going to be make of map, and lock is going to be sync.mutex. So this is the default value, but this make we need to do in order to allocate some memory for the key value map. I know there might be some better name for this, but yeah, I'll update. Name this better. So yeah, so now we got a db struct in. So whenever someone is let's say writing to this, we don't want to directly give them access. We want to take the key first. So I want to what else is there? Okay, we need to lock this, and after that we need to unlock this. So if you see, we first lock it and then write to it and then unlock it. And similarly here, when we are reading this, we need to say db dot lock dot try. Okay, not try. We need to lock this, but I'm not sure if we need to lock it actually. I think reading is fine, but still we'll just lock it. I'm not sure actually. Yeah, so we try restarting this. Okay, undefined db. How is it undefined? I don't know, how is this undefined? Okay, I mean here, no. I guess, why is this undefined? Not sure actually. Should we name this something else? Yes, name this view. No. Is it because of the package? I'll do one thing. I'll move this here. Yeah, it's a package. So if I do this, I get an OK. If I do this, I get the value. So that's working good. So the problem with this again is it's not persisting anything. Yeah, so the working is good. So if we go here, if you look at the diagram, we are doing this. We got our in-memory DB here. But again, as I said, the problem is we are not storing this anyway. So the one thing we can do is we can, whenever you are putting the key, we can just write it to the DB or write it to the disk. But as you know, disk writing takes lot of time that the in-memory DBs cannot afford. So there is some other way. In Redis, we have something called wall, the write ahead log. So this is usually used for crash reporting and crash recovery actually. So what this does is, So whenever we get any operation like put or get, usually put, whenever we get that, we just write into this log the first thing before even writing it into the map. So that whenever this crashes, right, we can see this and we can build the whatever was there in the write await log. So right now, before going into the persistent layer, I think we can start with this, because right now if you see our servers, when we restart it, we lose all the data. Wait, is it? Yeah, if I do this, it gives me 400. So I don't want this to happen. I just want, whenever we restart, we want initialize the database by reading the wall, and then populating the map. So wall is just a file, and whenever we write to it, we read from it whenever we need. So that's a thing. And before even going to that, we need to see how the format of wall, we need to, it's our own format, but we need to actually make sure so that we get the offsets right. So what I mean by that is, whenever, because you are reading to disk, all we do is play with the offsets. Offset in the sense the position of the byte, which byte you're going to write, from which byte to which byte does this, or are you reading from. So for example, we are going to store a put operation, let's say put, and the key is going to be k, value is going to be v, right? So this is the basic format. So on, we have this repeated in, basically we are writing this to the end of the file, nothing else. And whenever you read the wall, we read in batches of 3, so that we can get, this is a put operation and we are reading it, we will have a key and value next after the put, this thing. In the future, if we get any other operation, let's say get, okay, so then the get is not going to have 2, because we're not going to have any value, because we want the value. So get is going to have only one parameter, but the put is going to have 2. So we create our own rules like this. So for example, for now, let's say in disk, I think you don't want to use much memory. I don't want to say put in order to say put. I just want to say 1 and the key and the value. So 1 represents put. We have to take it like that, because it's not necessary to say that we don't want to spend 3 characters in order to say what just 1 byte could do. So we say 1 kv, for example. So yeah, this should, let's try actually. So I'll just before writing this, when we get this, immediately we're going to write, just write to wall. So the format is going to be 1 key and value. Okay, so this is going to be batch of 3. So the another problem is, yeah, so if you start, we know that 1 is put, right? And so the next is, so let's say this is some key value. In disk, we don't know what is the starting and ending point. So let's say if you start from 1, you need to know until which, how much the length of the key is going to be, so that you can read the next, let's say n bytes, right? So for that you have to say 3 here, 5 here, if it makes sense, because 1 stands for put and 3 says that the next 3 bytes are going to be the value of the key. So we read KEY. These actually aren't KEY, but the ASCII characters of those. So let's say some like this. So 81 is going to be K, 23 is going to be E, 42 is going to be Y, something like that. And for simplicity, I'm just putting it as key. And next 5 is going to represent the next 5, the length of the value is 5, and it's going to take up the next 5 bytes. So we need that. So what we're going to do here is key size is one thing, and then here the value size. right? So we're going to write that to the wall. So technically this is persisting, but mm, this might act as the uh, actual DB, but it doesn't, because there's another reason to that. Is it is a wall actually means that a write log, as I said, but we just append this to a file. Append in the sense we just, whatever request we get, whatever data we are writing, we just write it to the end of the file, and we don't need to search anything because we just want to populate the database. We read the file and we just whatever the keys and values, we just populate it. So the problem with this is that whenever you want to, let's say, search for a key, you don't know where exactly it is. So you need some more powerful data structure for that, like a B tree, in order to store that and retrieve that much faster than this. So this doesn't work for actual DB storage. This is just for the error recovery, or in our case to populate the DB. Yeah, so let's continue with this. So the actual key, so what we need to figure out is how to write bytes to a file and how to convert string to bytes. I think we can do the second one, but the first one we have to see how to create a file and write bytes to it. So I think we need to have a file created already. I think when we start the server, right, we need to have, let's say, os.file new file thing. Does this throw an error? So we don't want to throw an error when the file doesn't exist. We just want to create it. If it exists, then just ignore that. That's what we want to do. Okay, I think we can try open. So wall. So this says, oh, okay. So the actual file and the error. So for now I'll do this. If error is not null, then I'll just not allow the server to start. Right, so let's try starting it. Yeah, we got that there's no file or directory. Let's create that and then start. Yeah, I think this should do in order to read the file. I think that we could hold on because we don't want to initialize now. We just want to write to it whenever we get a post request. So here we have the file here. Okay, where is the file? I think we haven't enabled it. Yeah, whenever we have a file, right, we just want to say f.write and the bytes. So for that we need a list of bytes. We need to yeah, you can do this. For now it just, or I'll just say data is of type. So I'll put it here. I have the data, and so what I need exactly is the byte value of key and value. So right now if you see this, we get, if we do ordered key, that's a string, to convert that, I could say this, I think. Yeah. So before that I want to append these things. Yeah, the first one is 1 dot constant to byte. Okay. Oh, okay, that's a single byte, right? So yeah, we do that, and then we have the key size. That's going to be c dot where is the key? Oh, sorry, it's r dot key dot length. This is a string. I think we need to do len of this, and after that we need to write this. How do you append? Can I do this? Okay. Okay, it says I could do this r dot key dot, and similar way I could do for the value. Yeah, this could be anything. What would I do then? This the key is going to be string, the value is going to be interface, right? So that's, we have to see how to convert that. Gob encoder, it's too heavy, I think. How do I get the bytes? No, I don't want to do this. Okay, they're using Gob. Okay, it's okay, I think to create that. Okay, so what we're going to do is we're going to create a buffer. Bytes.buffer. And I think I'll just copy this. And buff. So we are going to do this here, and log dot fatal f dot error encoding value to byte. So let's stop there, and then we could write I would say buff dot bytes. This is going to be the len, and byte wrapped up on that because everything is a byte here. Buff dot bytes. I hope I have done this the right way. and now I want to append everything to the wall. So right now we don't have the option to delete a key, so that's one thing. Because if we want, we can make a flag active or inactive, and then what is error here? Oh yeah, so I think we can write it right append to file. But we need to open with this flags. So we should say open file. That's a permission. Yeah, so I think we could write this now, right? The data. I think this might return error as well. Yeah. So this is a discussion they were having recently on the internet, that this error handling is very tedious in Go, but I prefer this actually because I know exactly which error is handled where. So yeah. So let's say this and then do that. So I think we could try this if it works. Okay, so let's try writing to it. Okay, we got something, but the important thing is we have to check the wall. We have something written here actually. If you see, we have the one here, right? And if I open a new tab and see, it's 1634 bytes. I think is it that long? Okay, let's verify. So now so let's create another I think it should append to that. Yeah, 2 is at the end here and 1 comes first. So if you see this here, it's done wall, let's say. Yeah, so this is what actually is in our file, what we have written. Yeah, so there is data coming in. So this is, I think it's okay, but in order to actually verify this, we need to read this again when we're initializing our DB here and populate that. So after doing this, what I'm going to do is I'm actually going to attach a function here to DB and say init so whenever I say d.init, it initializes it populates by reading from that file. So what I'm going to do is again I could actually I haven't closed this, that's very important. So I'm just thinking I don't want to pass in the file here. So with the DB I'm going to store the file pointer of the wall. So this is of type os.file, right? So I'm just say wall file pointer, which is going to be os.file. let's pause this for a moment. And whenever you are initializing this, right, you could do this and initialize this as wall file pointer, and you can just say f. The benefit of this is that here you don't need to open the file because it's already open when you say d.f, sorry, wall file pointer. That should do the work. So now what we can do is d dot all file pointer dot read. Okay, reads up to len of b bytes. Okay, I want to read all. How do I read all? Read entire, read line. You have to open it and then you could do that. So buffer.io has a reader which reads line, but I don't think that's for us. Yeah, that's not here. So this is in which package is this? Buffer.io, right? Okay. We could see the read line here. I think what we want to do is read the entire file, because for now I don't care about that. So is it possible to read file? No. We could give the read a huge byte array and then make it fill that. But still, I'm reading this. Is there not a standard way to do this? Okay, I'm opening that file and then we are saying to do dot open, but we can't do that because I was saying to open file, then I write open file. Do we have open file? No. Can you do read file? Okay, this is not this. So then we get the data. and the other. Yeah. So the data is a byte, so we convert this to a string. Actually no. So we have to, I think we can skip the first byte because the first one is 1 actually, literally. Let's skip from the second one. Okay, because we could handle it afterwards if there are multiple commands. The first one is the length of the key. Is that's going to be how many bytes? So it depends on what we are writing. So here byte of length of something, so len is going to give us an int. So int is in size in Go. So it's 8 bytes. So so let's say key size is going to be int of date of I think we have to convert this. So there are many conversions happening when you read from a file. So I have to say go here. So yeah, we could do this. So this is key size, and this is going to return us a uint64. Wait. Okay, let's see. So 1 2, is it 8 or 7? Let's try 7, and let's actually print size. Let's print that, right? So here now we could do v dot, yeah. Where exactly is it? Length 6. What? Because the read file gives the entire thing, right? Let's print that. Length of 80 to 24. So index is out of range. Why is it out of range? Why is it giving index out of range? I think it's something related to this. So let's print that 128. It's all 0. You know what? Let's print that. We could use a debugger, but why are there these many zeros? You know what? I'll delete the wall, create again, and now try. Okay, so I'm going to try again. I have to comment out that init. So we have 1. You see the last 3, 5, 8. So these bytes are the one getting populated. So what are these? Is it because it's 64? Yeah. Yeah, it might be because, but no, it's not because of that. Why are we writing this much? Okay, so okay, we have 100, right? Yeah, we have the 100, and then we do this. Yeah, that makes sense. If I do this, and again delete this, add this, again comment out that. Cancel this, come back, do the init, and then see now. Yeah, now I'm getting the correct data back, but still the u into 4 in 64 is breaking for some reason. Okay, I don't think it's actually I think I could just say rate of 1 because okay, see, size I have, okay, let's say size is 3, right? I have that with me. It's anyhow in 64, so that doesn't make any sense. So I have the key size, so I know how much to go, right? So I can go like this. So see, if I do key is right string of this, from the first one is going to be the flag which is put, second one is going to be the key size, the third index is where the key starts from. So from there we are going to go till the key size, whatever the key size. So it's key 3 plus key size. Let's try printing that. So the key size is here, it's what is it, dat of 1, right? wo, so 1 is sorry, it's 3, right? So it's 0 1 2. Okay, it's from 2, not from 3. Yeah, we have 2 here. So if you see the key is 2, we got that. So now So we are going to do the same thing. I'm just going to store that in a variable. And similarly, the value size is going to be 3 plus key size plus 1. So this is going to be so from where are we going to, so if we are going, so the first one is the key size, so the second one is the key size, and let's say we have this three so 116, 119 and 111, those that stands for 2, and the next one is 6, right? So this is whatever we had here plus 1. Yeah, so this is what we had here plus 1, and this is what we had here plus 2, right? So that's the starting point. So this is 2, and the ending this is going to be so this is the size of value, and this is going to be it's going to start from here, so it's this plus 1 until 6. So this plus 1 plus val size. Okay, finally we just try to print. I'm not sure if this is going to be correct. We'll just print the key and value. I add, yeah, so it's not exactly right, but somewhere I'm missing something. So key is correct, it's 2. So let's put that in separate. Yeah, so key is correct. The second one, the value is something. Okay, it's maybe it's not a string. It can be anything, right? So let's say if I delete this and again create a wall, again go back, make this a string here. I try to start the server and give this a hit, come back, try to restart the server. You see, I get the 200 here correctly. So the problem is the type of the integer, right? So this type must be seen, what type we are storing. So if the I think we can do switch val type. Is that how you do this? String is not interface. Okay, we could do switch type. Go. Yeah. Switch v is like a val here. This could be anything, it's just not string. So let's say have string of bytes to int, but I have to know the type, right? That's the pain point here. So maybe when I visit here, like when I hit that, when I write to the DB, I even write at the end what type is it. So for example, I could say 0 is string, right? and 1 is int. It is something like this. So for that I need to get the type of the value. So here, because we know that value is what is it? So if I say c dot um, how did we get the r dot value? So we can do switch on this, right? R dot, so not r dot value. Yeah. And there is a case of int so we have these three. So if it's a string, we are going to append 0, else we are going to append 1, else 2. We don't know what this is, but we're just appending 2 for now. And when we get this here in the init, the last one is the type, which is the len of dat -1. So if type, I think we can do switch type. If it's 0, then break. Case 1, it's break. Case 2, it's break. Yeah, so if it's case 0, then value is going to be very simple, which is this. Yeah, so we need to convert the bytes to int in Go. ATOI. Okay, so they are saying we could do strings.at strings. Okay, that's your converter.at OA of string of this. We don't know what this is. So for now we could do where val is an interface. Right now we are ignoring the error, and we could just print the key and value. Again we need to remember, we need to erase this and again store, because we have updated the format of our val type, because we have added that type information here. Let's see if it works. So we just need to start the server. Okay, we need to, why is it failing every time? Start this and then create a key, again come back, initialize it, try to start. Okay, we get this, but if we change this to 200, do we get the same? Okay, I'll try doing this. Where is it nil? Okay. Not sure why exactly it's nil. key is 2 and the value is should. Okay, not sure why it's giving me. So yeah, this might be a little confusing. So value is nil. We have to see what's the type of. Yeah, we have to see. I could see value. Oh, it's float. Wow. Nice. So okay, for float, we want to float. Okay, I'll do this here and I'll update this to 3 here, and above this I handle this as well. Okay, how do I convert this to, can I do float here? No, bytes to float. Parse float. Okay. Four should do. Yeah, so case 3 I don't know. I'll just break. Float 64, but I don't know why it's not parsing it exactly as we need it to. Because we didn't do 2. Again, we have to delete this. Again, we have to do this. And here we have to just comment out in it. Start the server, add 200, and again uncomment it, restart the server. But we're getting 0. Where are we getting 0? Yeah, so the problem is this is just for the first one. So for other multiples we have to just loop through it, and I think it's pretty late for me here, so I'll just end the stream. So this might be the part 1, and part 2 will be where we will get this working and get the wall working, and then after that, if we continue doing this, we could do the part 3 where we could actually store data in some persistent disk storage, not just with val like append only thing. We could use some kind of data structure to store on disk. That would be quite interesting, but still that is a long shot. I don't know if I'm going to do that, but we will do that. Okay, that's it for today, I think. Let's meet the next stream where we will be writing the val entirely and fixing whatever is wrong with the val. Okay, thanks for watching. Yeah, thank you and bye.